So as João mentioned, I'm Pedro. I'm co-founder and CTO of The Newsroom. And I'm going to be talking to you a little bit about the RAG system that we've built to help journalists validate information at scale. And essentially, I'm going to tell you a short intro into how we built this system, but I'm going to focus specifically on what were some of the roadblocks we faced in building the system, and what were the strategies we took to kind of overcome those issues. So hopefully it will be a very practical session for all of you. And first of all, I wanted to start with why did we decide to build this? Why did we decide to go after this problem? And surely a lot of you have felt already that right now we live in a moment where there is a huge information crisis. So never before in the history of humanity have we produced as much content as we do right now. And right now, generative AI is not really helping much this issue, right? So there's an estimate from Interpol that says that by 2026, so in just 2 years from now, 90% of new content going online may be AI generated. Now, there are a few different estimates of what this might be. This is not consensual, but there is a generalized worry that in the very near future, more than half of the content that we will have online will be AI synthetic content and not human-generated content. And this poses a few different issues for how we operate. One of them, which you may have heard of, is what's called model collapse. So right now, a lot of the big AI systems we have and a lot of the large language models are trained mostly on data that they scrape from the internet. And up until now, most of that data was generated by humans. And if we reach a point in which the majority of that data is actually generated by other AIs, this leads us towards a point in which the new AIs being trained will slowly decrease in their performance, and this is what we call model collapse. Now, besides this, there is a big worry that I consider much larger than this, which is that this huge influx of information has been leading already to a big influx in misinformation and polarization. And so we see huge amount of information being shared online, but also it's becoming much cheaper, faster, and easier for you to produce false information and propaganda at scale and distribute it in a very easy way online. And this is why the World Economic Forum currently considers misinformation to be the biggest risk for our society in the short term, but also even in the long term, if we look at the next 10 years and beyond that, it is the biggest risk right after the climate crisis. And by the way, misinformation and polarization also has a huge impact on things like the climate crisis, because if we don't manage to have a base understanding of what are the base facts, if we have a growing polarization, it's going to be much more difficult for us to reach a consensus on what are the actions we need to take to actually overcome some of these issues. And so this problem is what we've been looking at over the last 4 years at the Newsroom. And we understood over that time that this information ecosystem is becoming really difficult to navigate, not just for readers, but also for journalists and content creators in their day-to-day work. And so we've been building AI solutions for journalists specifically, and one of the key solutions we've built is a system that allows journalists to validate information at scale. So if a journalist has a specific type of information they want to research or they want to validate, we're able to cross-reference that information across specific sources that that journalist trusts, and so it's highly personalized to the journalist, and we're able to tell them whether those sources support that information, refute that information, and do it in a very transparent manner so that they can see exactly who is saying what. Now, the backbone of this is a RAG pipeline. And so let me take a step back here and talk about how does the typical RAG system work. So a RAG system, RAG stands for Retrieval-Augmented Generation. So it's a generation model that retrieves data in real time to give its answers, to generate its content for the user. And the easiest type of example I can give you, which is a real-life example, is if you take an LLM like ChatGPT and you plug it into a Google or an internet search. And so what you do is, if you as a user ask a question to this system, like for example, what was the weather in Porto yesterday? Right now, LLMs are not trained in real time. And so they've only been trained up until a certain point in time, and they won't be able to answer you that question. What you can do, and that's why RAG systems are important, is plug this into an internet search. The system will say, okay, I have this query from the user. Let me search this online. Let me take the first 5 results from Google and answer this question based on the information in those 5 results. Again, this is a very simple example, but it illustrates very much what the flow of pretty much any RAG system is. So any RAG system starts with loading documents. So you scrape documents or you have documents internally. You pre-process them, so you chunk them, you split them into pieces, like sentences or paragraphs. You vectorize that information, and you save it in what we called a golden record, so a database that you have. In the example I just gave, this golden record might be, for example, Google, right? Google has a lot of documents that it pre-processed, it's split into pieces, vectorized, and has it saved in servers all around the world. Now, when a user asks this question, what was the weather in Porto yesterday, the system will retrieve documents from this database and rank them, like getting the first 5 results from Google. It will then pre-process that information and send it back to the LLM and say, hey, there was this question from a user, there's this information online related to the question, now reach a final answer based on all of this. So that's the general flow of most RAG systems. Of course, there are differences on it, depends where the data comes from, etc. Now, when we implemented our RAG system, we went into a few different roadblocks that I want to talk to you about. And we explored a few different strategies to overcome those issues. And so I'm going to go through 5 big roadblocks that we faced and what we did. And the first one is, imagine that you ask a question and the information you need is not in the golden record in the first place. So you don't have that information available in your database. So I have an example here. So I asked Claude, in this case, from Anthropic, which candidate won the latest US election debate. And Claude isn't connected to the internet. And so what it replied to me was, I'm sorry, I've only been trained with data until April 2024, and so I'm not able to answer you this question. Now, how can you overcome this problem? There are a few ways. The first way is what I just talked about earlier, right? You can do a real-time search on the web. Now, there are a few reasons why you may not want to do this all the time. So first of all, it's costly to do it. So if every time a user makes a request, you need to do a search to the internet, this may be quite costly. It may take a lot of time because you need to chunk those documents in real time, vectorize them, compare them. And for certain types of data, the traditional search systems, search engines, don't index them in the most efficient way. So for example, at the newsroom, we use a lot of data from academic reports, we use a lot of data from PDFs, long documents like UN documents, even proprietary data that we have, or statistical data that tends to not be very well indexed in a system like Google or any search engine. And so the solution we went with was that we have a series of sources that for us are very important because either they're used a lot or they're not properly indexed online or they're not available online. And we have an hourly loop, so every hour we go through all of those sources, we identify which information is new from those sources, we pre-process them up front, and we save them in our own database. And so when a journalist comes to query our system, we first try to retrieve information from that database. If we have the answer to it, great. If we don't have the answer to it, we go expand that search through an internet search only limited to specific sources, specific places in the internet. Now, this is great, but what about if only part of the information is in the golden record? So I asked the same exact question to Perplexity, which is a system that is connected to the internet, so it has some real-time information, and it gave me this answer. Based on the results, Kamala Harris appears to have been widely viewed as the winner of the debate. Now, if I'm a journalist, one issue I may have here is, first of all, I will look at the sources that are listed, and there are only really 3 sources that are used to give this answer. And I might be unsure about whether this answer really covers the wide spectrum of opinions on what happened in the debate. And so This is really important when you think about the RAG system that you're building, which is the data that you're using as the base of it well balanced, first of all? And second of all, what areas is it really critical for you to guarantee that the data is well balanced across? So for us, there are two areas that are really important. One is geographical breadth. So we want to make sure that the sources we use are global sources. They don't just show the view, for example, of the Western world or the English-speaking world, but they're actually global. And second one is the opinion spectrum. We want to make sure that when there's a question asked, the documents we retrieve give a broad set of opinions on what happened. And so if you do the same query with our system, you end up getting a big range of sources that have slightly different opinions about what happened in this event, as well as some sources that are not only exclusively US focused. In this specific case, the solution will be exactly the same, or the answer. So there happens to be pretty wide range of opinions that support that Kamala performed better in that debate. However, for a journalist, you're able to have a much more robust set of answers to work from because you know that you're looking at the full picture. Okay, so this is the first roadblock, which is you don't have information in your database, in your golden record, but what if the information is there, but you're not able to retrieve it or not retrieving all of it? And so here's an example where I asked a two-part question to ChatGPT. I asked which party won the Portuguese elections and how have they formed government? And what's interesting here is that ChatGPT is really good at answering the first part of the question. It says AD won the election, but then it ends that question by saying the government likely involved cooperation between XXX. And so it hasn't really been able to retrieve the full information I need to answer this question. And when this happens, so when you know in your RAG system that you have the information you need in your database, but your system hasn't been able to retrieve it or retrieve all of it, one of the first things that you should experiment with is different chunking techniques. And so I mentioned in the beginning, when you have a RAG system, when you're loading the documents, you chunk them into pieces, like sentences or paragraphs, for example. And this has a huge impact. The way in which you do that chunking has a huge impact on the performance of your system, on the accuracy of what is retrieved. There are three types of techniques that are very frequently used when it comes to chunking. The first one is what's called structural chunking. And this is very much the example I gave with sentences and paragraphs. So you split out the document in the specific structure that a document is on, so like sentences, paragraphs, etc. But this has some limitations. Like, for example, you may end up with chunks that have very different types of sizes. Some might be very short, some might be very long. And this can create issues down the line. And that's why there is a second type of technique, which is called the fixed size chunking. So in this type, what you do is you define a size up front. So you say, I only want chunks of exactly 1,000 characters each. It doesn't matter if they split sentences in half. I'll just always use 1,000 characters. They may have some overlap, and that's it. This, of course, has a different issue, which is you may lose some semantic context, right? Because you may break a sentence into half. You may break information in places where you don't want to break it. And that's why there is the third big technique, which is called the semantic chunking, where essentially what you do is you still break it into sentences or fixed pieces, but you see if two consecutive sentences are actually quite similar and quite likely to be talking about the same topic, and you put them together if that's the case, and you only split when there's a change in the topic being talked about. Now at the newsroom, we actually used a different type of technique from what is usual. What we did was we built a model that we called the claim extraction model. And what happens is whenever we load a new document into our database, we first extract all of the different claims from that document. And a claim is not a sentence, it's an atomic piece of information. So for example, it might be the AD party won the Portuguese elections in 2024. So it's one piece of information only. We store all of these in our database, and we do the exact same process when it comes to the query that the user is asking. So in the query I showed before, there are actually two pieces of information being asked about before. Who won? How did they form governments? And through this process, we're able to rank the claims, all of the claims that we have, and cluster them and say, for example, okay, these two claims are actually saying more or less the same thing. They have the same type of information within them. So I really only need one piece of information from there. And this other piece is answering the second question. It has one piece of information that I care about. And so you're able to really effectively do a match between what is being asked and what is the information you have on your database. So that was the second big roadblock. Third big roadblock is, okay, so I have the data in my knowledge base, I'm able to retrieve it, but there's conflicting information here. And so I asked Claude again this very polarizing question, which is, what should you pour first? Should you pour milk or cereal into your bowl? And what it gave me was, it started the answer by saying very clearly, the conventional approach is to pour cereal first, and it gives a lot of, I agree as well with pouring cereal first, it gives a lot of arguments around why you should do that, and then just in the end it shows a very little comment saying, well, you can also pour milk first, and here is one argument of why you might be able to do that. Obviously this is quite imbalanced, right? It's really only focusing on one opinion, much more than the other one. And what we did here is, because we have all of these claims already extracted from the documents, this allows us to be much more effective in actually clustering different opinions from a specific query. So we're able to see, for example, very efficiently that there is a cluster of arguments that is pro-milk first, there's a cluster of arguments that is pro-cereal first, and then we can match these two and actually say, okay, these two have a conflict between them. They disagree. There are two big clusters, so two big pieces of information, but there isn't a consensus around what is the answer to this question. And this allows us to say, okay, this answer is actually not a yes or no answer. This answer actually requires us to show pro one side and pro the other side and go from there. Fourth issue, and I'd say this is one of the most common ones, and one of the ones where the solution, there's an easy solution that can have a really big impact, and it is when you don't have the right context being given to the model. So imagine we ask this type of question: what symptoms can COVID virus cause if unvaccinated, according to the WHO? And your system may be able to retrieve this sentence from the database. Among the unvaccinated, the virus attacks the nervous system and can cause total paralysis. Now the problem is, if you just feed this answer into the system, they'll say, okay, cool, this is the answer to the question that's being asked. The problem is that if you have the context from it, this actually comes from a report on polio and not on COVID. And so the context here is really important for you to get the right answer to what's being asked. There is an easy solution to this, but that is not as widely available, as widely used as it should, which is using metadata throughout the entire pipeline. So when you are saving documents into your database, you shouldn't just save those chunks of information. You should attach metadata to it, like the date of that report, what's the title of it, who wrote it, maybe even if you have, what's the title of the specific section that showed up in. And so you should save that, and you should keep that metadata throughout the entire pipeline, so that then the final answer considers the context information is coming from. So fifth and final roadblock, or one of the key roadblocks we had is, okay, what if everything goes super well? You get a detailed answer that shows different perspectives, that is accurate, but it is very laborious to check. So if you have a human-in-the-loop system within this, like we do for journalists, a journalist will always want to check this information before they use it. And so what we need to do is to make it very easy and transparent for the journalist or your user to be able to go back to this and understand where this information came from. And that's why, for example, in our system, we don't just give what the answer is, who are the publisher, who are the sources that are supporting that claim, but the journalist can actually see specifically where within these sources that information came from and that information was validated. And so this makes the work of the journalist much easier. Now, these were the 5 key roadblocks we faced. Of course, this is not the end of it yet, so there is still a lot of complexity that we are currently working on. And to give you one final example, one of the things we're working on right now is highly complex relationships and what's called multi-hop tasks. So for example, if I ask this question, what did the current CEO of Twitter say about the CEO of Meta? The system needs to understand who these people are, who is the current CEO of Twitter, who is the CEO of Meta, to be able to make this link very effectively. Perplexity performed quite well here. We managed to understand the current CEO is Linda Yaccarino, and it said, actually, I don't have any information on her saying anything about Mark Zuckerberg. But there can be issues on this, right? And one of the things that is a big trend now in RAG systems is using knowledge graphs to support a RAG system. Knowledge graph, so I told you before, right now we're transforming documents into claims. Ideally, what we want to do is to be able to transform documents into a knowledge graph that really keeps the semantic relationships between entities. And so it's very easy for you to extract that this line is really what you want to answer the question you're using. What's the problem? This is very difficult to maintain over time and to keep the information updated. For example, Elon Musk used to be the CEO of Twitter, and he did say something about Mark Zuckerberg, so you have the risk of getting this as the solution, even though this is incorrect because he's no longer CEO. So these are some of the things that we are now working on. So working on how can we build these knowledge graphs from the information we have, and how can we keep this information updated. Final thing, just key takeaways. So if you're building a RAG system, 4 things I would highlight. 1, dynamic and diverse knowledge base. Make sure you implement good ways to have real-time updates into your data and that they work for the specific data you have. Retrieval techniques, if you're not being able to retrieve information you know is in your knowledge base, try different chunking methods and try different ranking methods. That can have a huge improvement in accuracy. Context aware, always use metadata throughout the entire pipeline of your RAG system. And finally, transparency in the outputs. We defend very much that a lot of these systems should always have a human in the loop. And if that's the case for your system, make sure that it's very easy for that human in the loop in the end to make the checks you need for your data. On that note, thank you very much.